Hello to all of you and welcome back to my SB2 channel. So this is the beginning of the thermochemistry chapter. We're going to be looking at the introduction for thermodynamics and thermochemistry. I need to talk about what are energy, work, and heat. We're going to be looking at the potential and kinetic energy. And then specifically for the potential energy, the most common one for us is the electrostatic energy that we're going to be looking into that. And we also have a practice for you at the end. Okay, so starting by introduction for thermodynamics, which is a little bit broader term for the study of the energy, heat, and work. And you can use that in your physical or even chemical process, right? Very helpful to understand how energy is transferred or transformed in different systems. Then we have thermochemistry, which is a branch of thermodynamics, focusing specifically on heat energy involved in our chemical reactions. It examines how energy is absorbed or maybe released during our chemical changes, helping us to understand and predict the reaction behavior and design efficient energy systems. Okay, so to continue our discussion, we should talk about the term energy. In thermodynamics, energy is defined as the capacity to do work or to transfer heat. That means these two, the work and heat, are going to be the two fundamental ways that energy can be transferred between our system and the surroundings. Okay? Now, starting by work, work is presenting the energy transfer that occurs when an external force moves an object or causes a volume change in our system. So we always need to have both of these. I need to have a force that does the work. I also need to have a system or an object that is actually moving, and we go by this d distance. So W goes by F multiplied by d. Then we have heat, and I can use either the capital Q or even a small q. They both are pretty common. And this heat is the energy used to cause the temperature of an object to increase. Okay, specifically, we're looking at the temperature increase. Okay, so to understand the energy, we need to grasp two fundamental forms of energy. The first one is kinetic energy. Think about it as the motions, right? Collisions, the movement that we have in our system. And if you try to calculate your kinetic energy, we need to know the mass of our object, so the size of the object, as well as velocity. Okay, and here's our equation. Your kinetic energy goes by 1 over 2. So don't forget that we have this factor here. And then I have the mass. We also have the velocity, right? Velocity squared. And as you can see, if I have bigger mass, I'm going to have more energy. If I have higher velocity, I'm going to have more kinetic energy as well, right? Okay, now the other one is our potential energy. And think about it as the stored energy in our system. For us as a chemist, the most common form of potential energy is our electrostatic potential energy. So we're going to be looking at the electrostatic potential energy in a lot more details on the next few pages. Okay, so follow me on the next page. Okay, so let's talk about the electrostatic potential energy. So this energy is going to be associated with the charged particles, and it's going to be proportional to their charges, which is known as Q1 and Q2, and it's also inversely proportional to the distance between them, which is known as D here. So let me show you my equation. My potential goes by K times by these two charges, and you divide that by the distance. And by the way, K is just the proportionality constant, which is given here. Okay, now because we have different charges, right? We have positive, negative charges, and we have different interactions between them. We're going to be looking at how having different charges can affect the potential. Okay, that is going to be all described to you on the next page. So follow me on the next page. So let's take a closer look to the electrostatic potential energy using very simple diagram here. So what I have for you on the left is my energy axis, right? And I have these two particles. They have the same color. That means they have the same charges, right? So if I have two positively or two negatively charged close by, they don't like it, right? They're going to repel each other. So we start from a high energy, but the energy is going to go down, right, as you actually separate the charges, right? So on the first state, number one, we expect to have high energy because we have a smaller separation and therefore greater repulsion. But as you actually, pull them apart and we have like bigger distance between them, they can have lower energy, right? A little bit more relaxed because now we have less repulsive forces between them. Now, the story is going to be different if I have positive, negative charges. They would love to hang around, right? They're going to have attractions. We're going to have a lot low energy here, so lower energy because we have greater attraction. And they're not going to be happy if you try to separate them, right? So as you increase their distance, their energy is going to increase, right? Because now we have less attraction between these two oppositely charged particles. Okay? Cool, cool. I hope that makes sense to you. Okay, so that brings us to our practice. Given the ionic radii as follow, which solid would have the lower, which means more negative potential energy? Is that sodium chloride or is that calcium oxide? Okay, so as you can see, both calcium and oxygen, they both have higher charges than sodium and chloride. Okay, so in terms of the charges, they're going to have more charge for calcium and oxygen, right? They also have a smaller distance, right, according to their, radii listed here. So that means calcium oxide would have the lower potential energy than sodium chloride. Okay, cool, cool. Thank you very much for watching this video. If you found this video helpful, make sure that you are giving a thumbs up to that. You can also share that with your friends. If you're enjoying the content and you want to keep learning with me, you can hit that subscribe button. That way you're not going to miss out any of our future lectures. I would love to hear from you guys. You can drop a comment below if you have any questions or topics that you would like me to cover in our future videos. Your support means the whole world to me and it helps this channel grow. Thank you so much. Take care of yourself and I'll see you soon on the next video. Bye bye for now.